So give me a second so you can ask a related question. Usually, which method gives you a larger value of estimated cost? Larger value of estimated cost. Okay, so far I can see both approaches are equally popular among you guys. Well, remember which one is likely to give you negative cost, which means you can actually have negative cost abatement or zero cost abatement. But that is idealized, right? So the bottom-up approach considers the potential, but it doesn't consider the economic incentives, right? It doesn't really consider the behavior of the market. So the bottom-up approach is kind of idealized. So they might give you a negative range of abatement cost, and they will also usually give you lower cost. So the second one is actually correct. A bottom-up method. The first one is correct for this one. A top-down method gives you a larger value because it considers what will actually happen and how the market will actually respond. But a bottom-up method consider what is possible technologically speaking, right? But it's just from an engineer's point of view. So it ignored the market behavior. So it's ideally, we could start with the most cost-efficient method, and then if we even need more abatement, then we can switch to the higher cost options. But in fact, there are many reasons why we may not go from the lowest cost options. Instead, because of government policies, because of preferences, and especially the fact that many of the potentials are in the developing world, and if people don't have the right incentive to use this technology, then actually we cannot always start with the lower cost options, and actually the cost will be higher. So a top-down method is more based on a general economic model. So it usually will give you a larger value of estimated cost than the bottom-up approach. And the bottom-up approach can be regarded as like the best scenario, or like the lower boundary or things like that. So it's usually an underestimation, the bottom-up method. So the first one is correct. Okay, now for the last few minutes, we can simply look at question 2, and 3 and 4 are kind of related, and we will have more time to continue with those questions next time, because our externality question will also be based on the same context. But today we will just solve part of it. So you can look at question 2. Maybe we can take a couple minutes reading this question. Okay, now assume people can drive from one place to another, taking either the highway or back road. And taking the highway takes 10 minutes if there's no one else using the highway. And of course, this is a simplified model, right? Taking the back road always takes 20 minutes. So we just would like to focus on one point, the efficiency point. So it's not very realistic, but let's just bear with it. So taking the back road always takes 20 minutes. And if there are other car users or other cars using the highway, then it's gonna take this much time for each person, for each car to arrive the destination. Suppose we ignore the cost of gasoline and assume that time cost is the only relevant cost. What is the efficient number of people using the highway? What is the condition for efficiency, first of all? The condition for efficiency is that the marginal cost, yes, thanks. Marginal benefit is equal to marginal cost for the society, right, for everyone. Now, we can focus on the Mars first. The marginal benefit of adding one car. What is marginal benefit of adding one car? The benefit is how much time can be saved, right? And like from using the highway to, from using the back road to the highway. So how much time can be saved? And so if there's no one else using the highway, then we can save 10 minutes. But if there are any other people using the highway, then how much time can be saved? So if we add one car, what is the time saved for that car? That is 20 minus how much it gonna cost you, right? 20 minus n divided by 50 minus 10. Or you can write it as 10 minus n over 50. So that's a marginal benefit for that car. And anyone else get benefit? If no one else get benefit, we can consider the negative impact on the cost side. Okay, then we can look at the negative benefit or the negative impact on others on the cost side. So in this example, what is the marginal cost for everyone or for the society if you add one car to the highway? For each existing car, what is the impact if now there's a new car coming to the highway? Now the highway get more crowded, right? And so what happens? Yeah, so they're good. So for all the other cars, now the time cost increases by 1/50. If you are following my screen share, then you can see my notations there. So for all the other cars, the time cost increased by 1/50. But that is for each of the existing car, right? Now it takes 1/50 more minutes. But there are already n cars. So that means the total marginal cost will be 1/50 times n. right? Because it affects each of the existing car if you add one new car to the road, to the highway. Now, if the two sides are equal, then that simply means 10 minus n over 50 is equal to n over 50. Well, you can calculate that and you can get actually n is, sorry, n is equal to 250. So actually, for the 250 first car, actually if you add it to the highway, it creates exactly the same marginal benefit and same marginal cost. So it doesn't matter if you add the 250 first car to the highway, right? So you can answer either 250 or 251. Both are okay. Both are correct. All right. Okay. Yeah, you can. Yeah, that's good. You can take a derivative. You can take derivative and see when n goes up by 1, c always go up by 1 over 50. Yes. So yeah, you can take derivative if you have a more complicated cost function or more complicated time function, right? Maybe n squared or something like that. Then taking derivative is a general method, general approach. And is that so? Yeah, if there are already 250 cars on the highway, it doesn't really make a difference whether or not you add one more car. So both are the same, right? For the 250 first car, he will be indifferent between driving on the highway or using the back road. So yeah, let me explain it again. So Selena, you are okay with this step, is that right? So this step is okay? So yeah, actually what is missing is that there is an n here. There is an n, sorry about that. So marginal benefit is how much time could be saved for that additional car if there are n cars on the highway already. So it takes let me finish. So it takes n over 50 plus 10 minutes for the n plus